Hey, y'all, what's up? Coach Hyde. So today we're going to talk about Newton's laws. Specifically, we're going to talk about Newton's first law. All right, so Newton's laws, we know we're dealing with motion. But first, let's just take a second and hold up. All right, what is motion? All right, so I had this cool little video you got to saw in class, drag racing. So check out that link if you want to know what drag racing is all about. That's my favorite kind of motion, fast motion, right? All right, so click on, we need to go to the next screen. There we go. All right, so first off, what is motion? All right, what is motion? So motion is the change of position of an object over time. So we look right here, we got some stuff going on. First off, this kid wipes out. Um, if that happened to me, if my back folded up like that, somebody call the ambulance because I'm not getting up. All right, but how do we know he's in motion? Well, because he's moving. No, that's not good enough. So if we look, he starts at the beginning, right, of the water slide, and then as time progresses, right, his body's position changes. So this change in position over time is motion. All right, look, my main man over here on the left got the belly rocking. I love it. I can relate to it. Okay, no shame. It's awesome. How do we know there's movement there? Well, let's focus on the belly button. Comparing the belly button to the belt line, right? There's clear vertical, up and down change of position over time, indicating motion. So let's continue. Depending on your reference points, motion appears to be different. Now, here we have two cars in each GIF. We got one car where both people are inside of the car together, kind of sharing the same reference point. And on the GIF over there on the left with the little kids, we got two people, one inside the car, one outside the car. So they kind of have two different reference points. And if you look at it, the motion is different. Okay. Yes, the car is moving with both of them inside of the car, but if you're looking at them, there's no apparent motion between them, right? They're together, the same reference point. Whereas over there on the other side, when they're in two different reference points, you can clearly see the motion between them. Now, watching this, I think that little dude is guilty of vehicular manslaughter. I see the tires spinning. He changes the direction. He accelerates by changing direction and by going faster into little dude, little girl. So I think there's some purposeful intent there. Watch out for that little guy. He seems to be having a ball doing it too. I know if I ever get in a car with anybody texting like that, I'm getting out. All right, so now we're ready to go into Newton's three laws of motion. In this video, we're just going to talk about inertia. Inertia is Newton's first law. So Newton's first law is the law of inertia. An object at rest tends to stay at rest. An object in motion tends to stay in motion unless acted on by outside force. Now this part here, right? This part says unless acted on by an outside force. I wish that was, I know it's necessary. I know it needs to be there, but for the sense of keeping it simple, I wish that it was left out, right? Because when you're trying to, it's hard enough to distinguish between these laws that it is, and when you start having force and multiple laws, it gets a little confusing for young minds. So it's specifically just talking about an object tends to continue doing what it's doing. That's it. Its tendency is to stay sitting still, stay at rest, or to stay in motion. It has nothing to do with the forces that act on it, other than it's just letting you know that if a force does act on it, then it's going to change its inertia, right? So exclude this force. We're going to exclude this force acting on it. That's Newton's second law, all right? So Newton's first law is just object at rest stays at rest. It wants to continue sitting where it's at. An object that is moving wants to continue to move the way it is moving, right? All right, rock and roll. So let's kind of leave that act on by unbalanced force to Newton's second law. All right, so look at my little man right here. All right, so the golf ball is at rest. It's not moving. It's going to continue to rest forever. It will always be right there in that spot no matter what. Now, if Newton's second law, if a force acts on it, it will move. All right, it's some kind of equal and opposite reaction with the third law, that's fine. But as far as just talking about inertia, its inertia is to remain at rest. Little man right here gets that golf club going, right? Creates some inertia, right? That inertia wants to continue to move in that circular, that centripetal path of acceleration, and he just kind of spins right on around with it. Also, if I rolled up on my leg like that, I don't think I'd get back up. I'm too old, too fat. All right, so kind of some other examples of some inertia here. Um, why this dude thought it'd be a good idea to hop out the train, I don't know, right? But he clearly didn't know about Newton's laws. So if you had to choose to be like someone, don't be like this guy. Be like the guy who is filming him. He knows about Newton's laws. He knows that his inertia, although this guy is not moving on the train, his inertia is still moving. He has forward inertia at whatever speed the train's going. It ain't going to end up good for him. This poor seal over here, right? Um, Inertia kind of gets him too, right? So he's just sitting up there on top. He's like, oh man, it's gonna be a good day. I'm gonna get a little stretch in, I'm gonna get a little sun on my belly. And then that inertia starts rolling. He's rolling down the hill. Um, it's actually pretty sad that a lot of these seals die from rolling off cliffs and stuff. I don't want to show you that in videos. It's pretty sad. All right. Um, just kind of talking about inertia here. Things don't keep it moving because most of the time, again, we're getting into Newton's second law here. We're dealing with gravity or friction on Earth, and that's going to stop these things' inertia. But that's more second law, right? That's forces, mass, and acceleration. That's not inertia. That's changing inertia. All right, so let's check out this right here. All right, explain what happens using Newton's first law. This is why you should wear a seatbelt in a car. So the babies or the toddler or whatever it is, inertia is moving, right? Just like the cars. It's going to keep moving. Still something changes its inertia. So even though the car stops, the inertia of the car changes, the inertia of the kid, right, has yet to change and continues, right? Just like you, if you're in a crash, you don't have your seatbelt on. Seatbelt is like an inertia catcher. It's going to catch your inertia and redirect it. Now, before we move on, something that was pointed out to me by a student, I'm a little bit worried about. Look in the grass, right? Right here in front of the car, right? So you can't really tell right there, but like right here in this area, y'all, there's tire tracks in that car. This is not the first time they've done this. It makes me a little worried. All right, so here we have the egg drop. You can put a card under a nickel, flick it out. I want to show you this because inertia at rest. But if you notice, the toilet paper, the doo-doo paper rolls, right? They're on top of the tray just like the eggs, except they move when the tray moves. So why is it that they are moved?
Up in room 206. Please up in room 206.
206, right? They are moved by the moving tray, but the eggs are not. Mass, inertia. The doo-doo paper rolls have much less mass than the eggs. They have much less inertia because they have much less mass. The eggs have much more mass, so they have much more inertia. So the little force of the little tray sliding out is enough to change the inertia of the toilet paper rolls, but not enough to change the inertia of the eggs. Now, the eggs, according to Newton's law, want to sit right there. They want to hover in space. Okay, that's inertia. Their inertia is to stay not just in the same vertical path. They want to stay right where they're at. We have to go into Newton's second law to discuss forces of gravity is what pulls it down, right? So pulls it straight down into the cup. If we were in space where there's no gravity and we did that, the eggs would just stay exactly where they're at. They would never even move, right? If anything, they might move up, over, or that way a little bit, right? So big thing here, mass is a measure of amount of matter in an object. Inertia is a property of matter. How much it will resist this change. The more mass you have, the more inertia you have. All right, now again, kind of talk about friction a little bit. Why does this metal get so hot? Why does it liquefy? Friction. 4 types of friction. You see all my fingers? 4. All right. Here they are. So you got fluid friction up here. So as the bullet travels through a gas, through a liquid, and back through a gas, those are fluids. So it's facing frictional resistance to those fluids. Rolling friction, well, I think we kind of get the gist of that. Sliding friction is not only on ice, which is a funny video I saw when I put slide in on the Giphy machine. And then static friction, it's the friction you face because of inertia at rest. It's the initial, when you're trying to move something heavy, when you first start pushing it, it's just harder to move. And once you get it rolling, it's not as hard. This is static friction that you face. Once you overcome static friction, it's no longer a thing. So as she starts to push her, there's static friction. Once she starts going, there's no longer static friction. All right, so that's it. That's Newton's first law. A little bit about friction or the different types of friction we can face. Um, again, these forces are more into Newton's second law, which we'll go into next. All right, Coach Hyde, hot sides, motion. Still recording? Where's my pause button at?